So welcome everybody to this LPPD virtual summit of June 2026, which LPPD arranged together with the LAF in Finland. And we have some very exciting speakers as always. And we start with Stephen Young. I met at least 10 years ago. We were discussing if it's even more. But he will talk about the basics of value engineering. So the stage is yours, Steve. If you want to introduce yourself more, please do.
Okay, so what I'll do is I'll go straight into sharing because I've got a slide on myself, so if that's okay. But yeah, welcome everyone. I'm really pleased to be able to do this. So hopefully everybody can see this.
Yep.
Yes.
Yes.
So today I'm going to go through value engineering, but with a little bit of a twist, and the twist being is all the other stuff it can do for you. And it's when Peter asked me could I do a little bit on value engineering, I was actually quite excited by it. And the reason for that is out of everything I've done in the past sort of 30 years, and I've done quite a few sort of lean transformations, this is the one that I would say, do it, do this one. You know, if you could pick anything, do this. Let's try and get my slides to move. Oh, here we go. Okay. Sorry, guys. There we go. So this is me. Probably. Sorry, guys. So this is me. Probably a younger version of me. And so over the past 30 years, I've worked in many industries. So a lot in medical device, but I've also worked in semicon, hydraulics, sensing, building security, software development. And a lot of that has involved sort of the contact with sort of lean and lean product development. So my field has been mainly around lean product development, although I have run a few business-wide transformations. Nowadays, I work with medical startups because I feel that a lot of the expertise that I've learned can be applied, and I can have a much broader impact on the business. So I'm not going to spend too much time on that. I've written three books in the past about various different techniques about product development, and these are sort of just just an intro really. But if people were interested, I can give Peter PDFs that he can distribute for nothing. You know, I always like to sort of distribute a bit of knowledge. So value engineering, for people that don't understand it, this one statement kind of pretty well sums it up. So enhancing customer value by engineering simplicity. So years back, one of the CEOs I was working for, I was the product development director. He said to me, right, I would like the next product in a much faster time. I'd like it around half the cost. I want it to be reliable. I want the manufacturing to be simple, and I want all the support stuff like the root cause analysis for our service team. I want all of that all at once. And I think sort of before I had exposure to value engineering, I would have said, okay, I kind of would do it and I'd start looking for another alternative job in the background. But after exposure to value engineering, I could say, yeah, I can do that. And I'm going to show you why. So if we step forward. So value engineering, I can't take any credit at all for its invention. That was this Lawrence Miles of General Electric. I think this was a revolutionary step in product development. And it's lean. And the reason that I would class it as lean is if you want to reduce the amount of work you do, reduce the stuff that you need to design. That's the very simple, area of it. And if you look at the the phrase at the bottom, the most effective and reliable part is no part. That's at the core of value engineering. So I love the pictures on the right hand side. I put them in deliberately because it sort of shows the innovation recently between your standard petrol car with a four-stroke engine and powertrain and all of the components that go into that, and our premium offering, something that you're going to pay through the nose for, which is your electric car, which has significantly less complexity to deliver the same end function. And the function being is to transport people. So if you're transporting people, how you do it is your choice. But if you look at the two pictures, if you think about the thousands of components in a four-stroke engine and in the gearboxes and everything like that, you're thinking that's a lot to put together. And there's a lot to go wrong. Whereas a direct drive motor or power, that they've been around for 40 years plus, they go straight onto the wheel through a relative gearbox. It's a very simple assembly. It's very reliable. So this is where the value engineering comes into play. So why do it in the first place? So most people focus on the cost aspect. So your cost of goods and your life cycle cost. And do you know what? It's pretty good for that. It's pretty good. If you want to knock out 50 to 80% of your product costs, then start this value engineering at day one. And I'll show you some examples where, we've got significant cost out, but there's a lot more to value and analysis and value engineering than just cost out. The charts here, the chart over here, it says in product concept, so concept evaluation in product development, you lock in 70% of the product cost. During the whole product development cycle, you lock in 80%. After that, you're kind of tweaking with it. If you want to get some cost out of it, you're playing with the 20% unless you're going to go into significant redesign. So doing this up front and doing this value engineering up front makes a huge difference. So this this one here, I was trying to try and change the expiration into something beginning with N, but I couldn't think of anything. And I could have had I could have had a nice instead of ice. But in this particular case, there's just these basic steps. So when we talk about this whole methodology, comes down to four simple steps, and I think that's what's so nice about it is there's no complexity. And these days, with like the Chat GTP and Claude and such like, it would do a lot of this work for you. So, when we go on to talk about functional analysis and functional mapping, all you need is a video of how the thing works, and it will do it for you. So a lot of that heavy lifting work has gone away. Once we've gone through sort of a functional requirements, let's talk about functional requirement. We're then in a stage where we can innovate brand new concepts based on function, not on what it currently does. And a good example of that is if I jump forward a couple of slides, if we look at a conventional way of setting requirements, we might sort of say, right, okay, we've got this mouse. And it's the same as sort of in cars, we've got this engine, we need more performance, we need better emissions. But that's almost driving a solution before you even get to the point of, okay, what is it that you're trying to achieve? So if you come back and say, what are you trying to achieve? What is the function that you're trying to achieve? And you say, well, actually, in this particular case, what I'm looking for is on a screen, I need to move something or select something. Well, that opens up lots of opportunities. If you think about modern voice recognition, for example, or touch screens. Well, let's go back to the voice recognition. If you can load in an app for voice recognition, effectively, it is the license cost of that piece of software. There's no hardware anymore, so you can get rid of the hardware. So there's nothing to go wrong in that respect. You can select things, you can move things around, and it's relatively no cost. So you've saved all of that unit cost. A function map for a slightly more complex item. This is a costed function map that I've done in the past. This is for a water system on a radiotherapy machine. Now, what's really interesting about this doesn't take more than a couple of hours, but the opportunity that comes out of this is significant. So it tells you about the overall design from the perspective of the top level function. So the top level function for this would be call the beam line. So call beam line, and how it drives it is a verb noun. It sort of says it pumps water, it monitors temperature, it passes electricity. So it's this verb noun combination. And you drive it all the way down to the individual components that you intend to use. And what's really nice about a function map, you can instantly see where the money's being spent. And you say, wait a minute, why am I spending so much money on something that doesn't add to the primary function? So you might say, wow, that's ridiculous. Is there a cheaper way of achieving the same function? Likewise, when we did this activity, what came very clear very quickly were that there were items which appeared to have no function at all, or no function that anybody knew. The components were there, but why were they there? And the second thing that came out of this particular one was the primary function wasn't met. And that is the key thing. It says it's control beamline temperature. It had no mechanism of control. It was open loop. So that had failed. So you're paying all this money for something that didn't achieve its end result. So that's really quite an interesting thing about it. So from some of the examples, the first one is an IVD device, and that device, they were really looking for some money coming out of it. The device was too much, and it had been designed, and the design house that had been working on it said, well, it's very difficult. We've always considered cost down in our design. We're not going to get anything out of it. The reality is, once we've gone through the methodology of value engineering, and we got back to function, the actual design team that had said no, it's not possible, came up with 26% cost reduction in that product from that was a 1 day event, 26%. So that's significant. That's a massive amount of money in this, but well, not massive. In this type of device, you're looking at a device that was around 60 to 70,000 coming down to around 40 in 1 day. I think that's good value for money in terms of investment in a tool or a methodology. That's pretty good. The second one is a radiotherapy machine, and it's the water system. So in that particular case, what it did was far more than the cost reduction. It got the 42% cost reduction because we had that target, we had to achieve that. But what it did more than that, it achieved the primary function. And that meant that other problems that system had seen for many, many years went away. So it meant the instability in the beam performance was affected by that activity. The third one, where I've got cost neutral, well, that was quite an interesting one because that one was about to launch, and it was the very first thing that I actually tried out functional mapping on, funny enough, and it was a setup tool. And at the end of the activity, we all came to the conclusion that the primary function wasn't being met and it couldn't be shipped. So And it was a lucky escape, what I class as a real lucky find. The first event, lucky find, because it was an expensive kit that would have done nothing, or it actually caused more problems than we started with. So you can see immediately that there's huge value to be had with this tool. And what I would say is there's so much more value in value analysis, which is a function map. The thing that I showed you where we've got the verb noun, where it's saying drive this or select this. And from a top level, we're saying, okay, we need to call the beamline, or we need to drive mechanism in the IVD, or we need to align leaves in the third one. It changes the way the engineers think. So they haven't been painted into a corner. So typically requirements paint you into a corner, and it sort of says, well, this is how it currently works, and we're just going to refine it. It's a refinement. And in that mouse example, it was all about, oh, make the mouse smoother, make it look nicer, but it's still a mouse. You're still going to end up with a mouse. Whereas if you just go all the way back and say, what is it that the customer really values? You can change your whole perspective to something that will cost you nothing. So you can cost something or cost nothing. But this isn't why I love value engineering. The reason I love value engineering or the value analysis piece is because it achieves so much more. So you do it and you get masses of gains. So here are 10 particular gains. So if you do a function map, for example, and you look at item 3, you immediately give yourself a fault tree. So if an engineer phones up in the future, they just say, you say, well, which function isn't working? Okay, let's have a look at the function map. Have you tried A, B, and C? It can only be A, B, and C. Immediately, you've got that fault tree. If you're doing risk analysis, and well, that's key in sort of aerospace, medical devices, military, your DFMEA, PFMEA, and hazard analysis are all linked to loss of function. So it's immediately eased that burden as well. Requirements capture becomes easier. The structuring of your systems level architecture becomes easier. So there's so much more to this tool than just getting some cost out. Don't get me wrong, it's great for doing that. But if you think about all those other things that I mentioned, time to market, if I go ahead, let's say if I go ahead and try and streamline an engine to get less emissions, higher performance, more more economical, I'm looking at quite a big program. If I'm using existing technology and integrating it, and I'm not trying to simplify the the electric motors and all this sort of stuff, but fundamentally they've been around for a very long time. You can say, is it easier to integrate than to start to try and squeeze that last 5% out of what you currently have? So, and the more you can get out by the functional analysis, the less you have to design. The less the service engineer has to worry about it failing. So your life cycle costs drop. The less the manufacturing people have to worry about it, because if it's not there, they don't have to build it. So much else comes as value. But then there's extra bits as well. So there's additional things. So I know there's a complete topic on why agile doesn't work particularly well for hardware. Well, what I've seen before is there's hybrids. So there's a lot of hybrid work going on with waterfall and agile to try and accommodate like an agile framework for hardware. But fundamentally, if you start to flow functions, they're fully contained and fully that you can, they've got a testable solution at the end. That means now you can work in a agile framework. So your subsystems can actually work. So because nothing works without the combination of software, hardware. It's no longer the functional aspect of hardware versus software. They work together. So there's another good thing for this framework. The next thing, so the other next reason that I love it so much is in terms of checking that the function actually does what you desired it to do. Well, you can do your verification test and you can do that, but it's a bit late to the game. If you do your functional analysis, you immediately identify that you haven't achieved the primary function or the secondary function, central secondaries. It helps you with your concept evaluation. So you can look at the complexity of a function map and say, whoa, that looks a bit complex to achieve this. So immediately you can weigh up concepts very easily. And then as part of the toolkit, you also get the should cost. So you can say, well, for this particular function, this is how many hours I should spend on that particular feature or that particular aspect, or this is how much I should be spending on that. So it apportions your cost and your man hours to the right place. Along with this whole tool set, you also have your low cost evaluation. It sits hand in hand with the value engineering. So you test out your functional kit with low cost, and you can see in here we've got lots of cardboard examples, and I think this shows, again, speed of development. So everything that I've told you about today is very rapid. To get you to a endpoint is a very rapid thing. And this is why it sits in the lean product development folder very nicely, is because lean is about the process of delivering something of high quality fast, not with more effort. I love this right, sorry, the left-hand example. This is a whole luggage scanner made out of wood, and I think it was a brilliant example of actually testing something before you go and commit to it. So it was achieving a set function, and they made the rapid prototype to reflect their thoughts in terms of delivering that function. If I could have done, I would have persuaded them to keep with the wooden model. But it's but I will jump back in a second just to one of the slides that just gives the methodology in a very simple way. But I want to go to my leaving thoughts before I jump back. I know it's a bit of a strange way of doing things, but that's kind of how I work. The one thing I can honestly say that in every company I've been in, from the point that I was shown this, I've used functional analysis and value engineering, and I have never ever regretted it. So that's number one. And the companies I've used it with haven't regretted it either. So I think focusing on this function changes the whole dynamics of the design. It reduces the level of risk that you carry. It enhances customer value. So there's another lean methodology ticked off, enhancing customer value. It significantly helps with the risk management because you've already got the function map that rolls straight into your DFMEA, PFMEA, and hazard analysis. So again, you're helping yourself and you're reducing your burden on other stuff that you'd need to do. Fault finding and knowledge transfer becomes easy as well because you've got a function map that you can describe how something works in very easy terms. And now with the likes of the AI assisted tools, a lot of the functional mapping can be done for you. And a lot of this methodology can be applied through the AI tools. And I would say, a lot of the post-it skills that I have are now becoming redundant and replaced by the AI tools. And I say it's a good thing because what you want to do is get to the point and get the people thinking immediately about how can we reduce the complexity of this function. That's where the value sits. So I'm going to just jump back a couple of slides if that's okay, and then I'll take a few questions. Is that so? The one I wanted to focus on is this one. So I jumped all around and I didn't really describe functional analysis in its core, core terminology. So really, it is talking about what the customer is willing to pay for. So what is it that if you were going out and saying, I want to buy a new watch, for example, what is it they are actually buying? Is it the watch, or is it the ability to tell time, look aesthetically pleasing? That's kind of what and how you achieve that could be actually if it can tell the time and it's a speaking watch and it looks nice. I'm happy with that. So you don't need the display anymore. You don't need the fancy housing, or for different users, it's different things, but it's changing it back down to what is it that the customer's really asking, and it's not those detailed requirements. So a function, if you look at this, it's broken down into this noun and verb, and the noun and verb can only be a maximum of 5 words, and that brings the teams together to really focus on what they really need, because someone could end up writing a requirement. So in this particular case, a primary function might be for a car to transport people. One of the a simple example might be to you could say it's a tin opener or open can. There are many ways to open a can. Pump fluid. There are many ways to pump fluid. Amplify signal. Cook food. You can see that these things could lead to multiple ways of achieving the same goal. Other functions that are included are things like appearance, noise, vibration, and feel. They're still functions and they're included. But once you've got those, then you look for the essential secondary functions that serve the primaries. And again, they follow this noun and verb right down to the point where you've got the component. So once you end up at the component, so a printed circuit board, a wrist strap, or a piece of software, you know that you've reached the bottom. But I'd say, regardless of the scale of the machines that I've had to function map, these things generally are done in a day. And if you think you can achieve anywhere between, for an established product, probably 25 to 40%. For a brand new product, anywhere between 50 to 80% cost reduction. I think that's a good investment of time, and you get everything else for free. And that's kind of where I wrap up, and that's why my end slide basically says, give it a go. What have you got to lose? So that's me. So I'm open to any questions. Uh, Colleen, I see your hands up straight away.
Yeah, fantastic presentation. And I have to say, the simple aesthetic of your presentation really translates into just how deeply you have gone into the subject matter, and have really removed a lot of the noise from your messaging. So, standout
Thank you.
presentation. My question for you is, I'm a big advocate for quality function deployment and FMEA, which can
Yeah.
often be so um, complex and intimidating. I'm wondering about another intimidating part of this, which is called trees, and I'm sure you've dealt with that, the technical contradiction that is sometimes used in these groups. And I'm
Yeah.
just wondering if you've had any involvement with that methodology
Yes, I have.
and how if you've found it helpful or not. And
I
I don't know how to
with
lower my hand, so sorry.
Yeah.
There
So
we go.
with Triz, I bring out Triz to provoke people's thought process. I don't use the contradiction matrix very often. I generally can see very quickly where the most appropriate contradictions were, or the most appropriate Triz methodologies would come into play. So for people listening, Triz it basically it defined that I think it was around 95% of all patents generated are actually adaptions, and by using these 40 principles, you can adapt a design to get a brand new patentable idea. So that was Triz, and Triz normally sits hand in hand with value engineering, but it's not necessarily needed. I think what's really needed is the function map that I think that's where all the value sits, the function map.
Hmm.
And in terms of the DFMEA and PFMEA, since I changed over to a functional based DFMEA, PFMEA, the overhead has significantly reduced. And I'd
Hmm.
say significantly. It used to be like you'd sit in weeks in a room with the engineers, but now we're talking about I can give this to an AI tool and it will generate a jolly good attempt based on the functional analysis because it knows what components were used and it knows the failure mechanisms of those style of components and it knows the function. So a loss of function, it can attribute a score into. So you're kind of 80% through before you even enter a room where you can't do that using the old method of, well, let's guess what it might be. So it's moved from guessing to something that's systematic and really nicely rounded. I hope that kind of answers.
Oh yeah, absolutely. Love it.
And I really like QFD. That would be my second favorite. The five uses of QFD. It's so that's my second favorite, just in case Peter's, interested. That's Is there any other questions, or shall I stop sharing? Oh, we got what?
Yeah.
Well,
Ville.
Villa. Sorry.
No worries if I can put my video. Okay, thank you. So you were talking about the primary function and that you are using the voice of customer to
Hmm.
define what it is. But I'm thinking that how you define what is like a voice of customer. I'm like from my what I have been used to do that we have, let's say, internal customers and
Yeah.
external ones.
Yeah.
And sometimes a little bit difficult or there's this noise or bustling that what is actually that they are wanting, and sometimes
Mhm.
it seems to be contradictions. So do you have any like tips or tricks how really then I can hear what is the voice of customer and really drown out the noise?
Yeah. From my perspective, the customer is always going to be the person paying for it. The internals are kind of the stakeholders, and that's kind of important. It's really important. So there's two aspects. So the external people, where you're going out and sort of saying, what are you actually looking for? What's the problem that you're trying to solve? What's the functions that you're kind of looking for? That's always going to be your top level customer perspective. But there's got to be the internal perspective as well, like you point out. And that's brought in by generally the product managers. And it is what you're trying to do is bring this into it's like a midway level that sort of says, Okay, that was the voice of the customer. This is the stakeholder view, and this is what we class as our perspective of the project you're going to deliver. So the product management take into account all customers and they round off to say this is the perspective for the product that you're going to deliver. With the primary weighting is always on, right, okay, this is what we can sell, guys. Because if you lose sight of that, it doesn't really matter what the stakeholders want. Yeah, okay, stakeholders, I want it more reliable, but you can't sell it. So who cares? I want it at this cost, but you can't sell it. So, so it's making sure that there's this very clear perspective between what is truly voice of the customer. So it's almost segregated off as voice of customer. And then this midway point is where it pulls in everything. And that's provided to the engineers who give the technical response to say, this is what we can actually do. So this is where they do the function maps and they say, we've taken into account both your external and internal. They've been weighted, that was weighted out. And this is now our technical response. And then there's some handshaking that takes place where everybody starts to agree that this is the right thing, this is the right solution. And then that becomes the technical specification. So that rolls into your system, subsystem, and detailed requirements. So it's that cascade, and it's that middle bit that is often missed. So
Yes.
it's I've seen it recently where it's been called a project. It's like a project. What's the word? It's not perspective. Perspective. It's like a project overview, which includes the business case, which includes internal stakeholders, which includes the whole reason why you got it, the stated intended use, and
The
the things
charter,
it must do.
the charter.
The charter, that's it. The perfect. Thank you very much for saving me from drowning any further. The project charter, and that works really, really well. And I like the picture in the background, but I'm not sure if that's something sitting on the roof rack or if it's an engine or sitting on the top as a spare. Does that answer your question?
Uh, Yes, thanks a lot. It answered my question very truthfully.
But again, it's these sort of things that I think in the books, it kind of describes all of these. I don't know if you guys have ever seen the Haynes manuals for cars, but I wrote the books based on the Haynes manuals. It will never make you an expert, but it will get you through it will get you through from the level of departmental management right the way through to full business transformation. And that's all of these things are described in that. So but is there any other questions or should we move? Oh, yes,
So, how do you say your name?
Steve.
Oh, Steve. Okay. I'm looking at your name on the thing and okay. Sorry, Steve, I came in late and so I'm going to apologize for that. I'm very sorry about that. But I can relate to your functional breakdown. I used to facilitate building those for actually diapers, which are quite complex.
Yeah, I'm sure they are.
Personal care diapers for babies, and fem care products and adult care products and all sorts of things. But I had a question. When you build them, how far down do you go? Because we used to we used to go all the way down to, from a system standpoint, all the way down to raw material and even down to centerline settings in the process. And I was just curious about when you build those, do you ever go that far? Or I was just
I go
curious.
to component level, but it's interesting. It's a very good question, and the reason it's a really good question is the function map always ends up the same size. So we
Right.
so and the reason for that is if I was doing a radiotherapy machine, the blocks that I get are at a higher level than if I was doing something like recently I've done an IV, sorry, a medical device that's a wearable. but the function map, if I look at it on the wall, the radiotherapy machine looks almost the same size as the that wearable. And the reason being is because your starting point starts off at a different level as well. So
Yes.
you always go to component level, but the level of component in the radiotherapy machine might end up at a function which is drive beamline, which would be a combination of, like, you'd have this chassis, this software, this element. So it'd be much higher level. Whereas right in the wearable, it will go down to the printed circuit board, a bit of embedded
Yeah.
software. But
Yes.
relative wise, they always go down to component level, and that allows you to
Yep.
see if a component is being used in multiple places, so it's got multiple functions,
Ah, yep.
or when you cost it, whether it looks relatively correct for the function you're trying to deliver. But it's that scaling that
Ah,
people
I see.
find difficult. But once you get the first three post-its down, in
Hmm.
you're done. You kind of, you're on a roll because it becomes intuitive. It's
Yes.
and it you're just following it down. I think the thing that catches people out is it's kind of reverse, and you probably found this as well. You don't start off at the point where if you're driving an actuator, you don't start off with the physical drive in the actuator. You start off further down where it might be the opposite way round, and that's what catches people out. And I said, generally I say, I don't care, just write the post-it, I'll put them in order.
Right.
And
Yep.
and that gets you there a lot quicker. And that's really what's important.
The other, I would just make one other comment that I found is that the ability to get the whole group on the same page and understand the product all at the same time, working it out together, was incredibly powerful as well.
Yes.
Yeah.
Like I say, in one day you can achieve more than
Yeah.
you can do in months. Effectively, you can
Exactly.
reduce your time to market
Yes.
significantly for that one day's investment.
Absolutely. Yes. Thank you so much,
Thank you. Thank you.
Steve.
Nick, nice to see you.
Yeah, nice to see you. Thank you. That was an interesting talk. My question comes from the perspective of me working at a design consultancy, and I'm wondering how a function map changes over the course of a project, and if you do go back and revisit it, or does it just filter down into the technical specification and detailed requirements? So I'm thinking, if, say, in trying to meet the primary function of a device, the concept or method that you use to achieve that causes another problem. Say it makes more noise than you anticipated. Noise was perhaps once a tertiary function on the function map, and now all of a sudden you've got a bit more risk. Does that sort of stay in the requirements documents, or do you ever revisit and update the function map?
It's a really good question, Nick, and I kind of leave the requirements at sort of kind of a draft level, and I use the function map as my primary. And the reason for that is the requirements, 9 times out of 10, I hate to say this but it's just out of experience, they come as a cleanup activity in many, many different ways, where the function map, you can use it to actually derive what you don't know. And really, about when you're doing any concept exploration, which a lot of your work is concept exploration, it helps you derive what you don't know. And it also allows you to look at the complexity that could result in the risk. So for the medical devices that you work on, you could instantly see from that function map, from that one day's of work, where the risk actually sits, and you can focus your effort in the right place, and you can also focus your manpower in the right way. So you might say, I'm going to spend equal time on everything, and that's not really a good use of resource. What you really want to say is, where is the good value for my people, or where would the value be best suited? And it's always around primary function and essential secondary. But where it really gains you extra time is all of that extra documentation that you normally sit with kind of comes for free, because you've got your function map and you say, well, once I've got the function map, that can roll straight into, you've seen the QFD, but it can roll straight into the QFD, and that will identify all of your ranges of unknowns. It can be used in your DFMEA, PFMEA, hazard analysis, because it's a loss of function. It can be used in the top level risk planning. So it can be used in manufacturing. And like I say, one thing, a lot of your clients would want you to deliver something that's delivering the customer value in the simplest form at the best cost. And what you could demonstrate to them is, here it is.
Yeah.
And you can come up with something that is unexpected. And that's the thing that I love about it, is it changes the paradigm of engineering. And it's one of those things, Nick, with yourselves and, your great team. It's the sort of thing that I would love to just come up and just do it for nothing. Give you the run through. It's kind of just because, it's that great.
Yeah, no, I'm sure we'd be interested to have that, to be on the receiving end. Yeah.
Well,
Thank
the
you.
offer's there, but thank you, Nick.
Thank you.
Cool.
So Colleen has gotten tired of the chat, so wants to talk. Come on.
Stephen, what is your preferred method in terms of a remote environment? Probably not your preference, being very hands-on with that function map, but have you ever done this type of work, but in a remote environment?
Yeah,
And what
lots of
is your
times.
preference?
Do you know my preference is I use I use one of the this will come with no surprise to you, but I I use one of the free tools that allows you to move post-its around online, because what I don't want is the reduction in flow of ideas. And if you've got someone sitting there typing stuff in, it doesn't work. So I use one of the free, I can't even remember what it's called now. But like you say, my preference is to be face to face and just do it. But if I just search up a free tool that will allow me to move post-its, and I get everybody just to move the post-its, write their own post-its, drop them in, and people get more out of that experience because it's learned by doing. And that's my whole methodology.
Yep.
Don't teach people something they're not going to use tomorrow.
Yep.
So,
I know
and
Miro board is,
yeah, that's one that I've used. That's pretty good. That's pretty good.
Okay, thank you.
Thank you. I should quit off this and allow other people to speak, shouldn't I?
Well, thank you, Stephen. Very good presentation.
I'll stop.
And let's stop the recording.